Hey class, it's Professor Nick Sensky at UNC Charlotte, and this is just a revision of Lab 2 video. I just wanted to go through the facade example a bit slower and explain what I wanted to do with that. And this might help you with your assignment. So, first things first, just go ahead and give yourself a single line that which you're going to use to generate your facade study. We're just going to do a linear facade right now, just a single kind of section. You could do this in lots of different ways, but for now we're just going to do a single line. So again, a line in Rhino from 0, 0 to 100, 0, right? And then we're going to reference that as a curve. Set one curve. There you go. And then from that, we're going to begin to think about these as, as datum lines in elevation. So that curve is actually your baseline. You might even call it the ground, let's say, where the building meets the ground. And again, we're ignoring like topological conditions and that sort of thing. This is just kind of a study of rhythm and proportion in your building. And then once we've got a line, we can begin to copy that line using a move component. So we're going to move that up and down in elevation according to some kind of parameter. And the first parameter that I'm interested in is just the actual height of the elevation. And in this case, I'm going to make it 18 units, 18 feet. I say the largest that this bay, that this story is going to be 18 feet for me. That's pretty large. So our second datum line is based on the ground, and it's going to be the maximum height of the building. And we set that to be a slider that's 18 units maximum. And so let's go ahead and call that maximum height. And it's a good idea as you go to kind of organize. This is a line that we're going to be using frequently, so we want to organize our sketch, our script, so that we have access to that. So instead of just a move component where it's just some anonymous line, it's actually the maximum height of our facade. The next thing I'm going to do is I'm going to take that and using that same pattern, just make a copy of it. And I'm going to change this to, this is going to be the window line. And the window line is the line at which our window starts and the kind of base between the ground and the window ends. And that's going to be, it's going to be a lot less than 18. So let's set a maximum height for that to be, say, 5 units. Okay. That seems to make some sense there. And then let's go ahead and do a copy paste of that. And then let's add a soffit line, and the soffit is the kind of lip that's above the window. And if we assume that there's maybe a roof here, we might call that the soffit. So let's change this to soffit. In this case, it's really just we really just have 4 datum lines. You could have many more datum lines depending on how you want to divide up your facade. But the soffit line. Now, this interesting thing actually, the soffit should be something that's below the maximum height, right? It's somewhere between this line and this line, and so a way to do it that might make sense to us would be to take to make it based on the maximum height. So let's take a subtraction component. Subtraction is basically A value minus B value is the result, and we want to subtract from the maximum height some soffit value, right? And then plug that into our move, and that's going to give us a line that's actually based on the height, so it has a bit of logic to it, right? And that's going to be our soffit line. Okay, so 4 lines: ground line, window line, soffit line, and then the maximum height. And in fact, just to make more sense, I'm going to move the soffit up here and move the ground over here. And that's really messy, but at least it's 1, 2, 3, 4 for our lines. That makes a lot of sense. Okay, I'm gonna quick save my file at this point. this, facade study 1, just so I have a copy of it. It's good to do that in case you crash Grasshopper. And we might kind of move our components over a bit and organize them. You can do this later, but anyway, so I've got all my components and my lines lined up. Let's go to work looking at the horizontal characteristics of it. Like, how do I want to start to divide this up? So take my ground line, and I could divide it, and I could divide that into some places to position columns. Okay, so I'm going to take divide. I might, if I know that this is a fixed length, I might just divide it by a certain number. So that's why a divide curve might make sense. Otherwise, I could use a divide length component. So I plug that in. That's going to give me a series of points that I can use to position columns, let's say, that I want to see in my building. Let's go ahead and add a slider for that as well. Let's see, and that's a number, right? N is just a whole number, so I want to use a whole number. And let's just make it really big. Let's say maybe 40 things. I have a lot of things there. Okay, so we thought about maybe that level of the horizontal. Let's go ahead and hide that for now. And then another layer might be, the number of divisions that we have in our windows. So let's take a look at that. That line is the window line, and so we could take another divide component, and we could put and connect that to the window line, and then that's going to give us a number of things we can use to subdivide our window. Okay, so now we've got some points in horizontal. And some points in vertical, and we can start to look at relationships between those, and we have our datum lines. Okay, so let's go to work starting to create some geometry once we've kind of arranged the things that we want to study. And this is extremely simple. Like you could certainly add a lot more layers to it, and a lot of different variations, but this is a very simple way to begin thinking about this facade study. Okay, so a way to create geometry that is useful when you have two lines, right, is to create a loft between them. That's going to create a surface. So we make a loft, and we want a loft from the ground to the window line, and that's going to be our base. So let's go ahead and call that loft base. So connect the ground line, and then remember I have to hold shift, and I connect my window line to the base, and that's going to give me that geometry. Let's make another loft for the window proper. So just call this window. And it's a single surface. So the window line, and I'm going to disconnect the ground line. Let's just disconnect everything for right now. So window line, hold shift, and connect the soffit. Gives us the window, the base, and then one last one, which is going to be the soffit. So we go from the soffit line to the maximum height, and that gives us, so that gives us three surfaces. Okay, and again, fully parametric. I can adjust it, and that's going to change. I need to rename this to soffit. And again, we can probably keep these straight. We'll come back to these later. So we have our lines, and then our planes, and then once you have a plane surface, you could extrude it, and that's going to give it some depth. And we can take our base surface, we can extrude it. Now we want to extrude it in a Y. You can look at our Y thing. So we've been doing Z quite a bit to move things up and down, but in this time, extrusion is actually going to happen in the Y unit, and then we're going to add a slider to it. And you can see that we're actually, since this is up in the Y direction, as we extrude this way, it's going to go out in that direction. We can do that, and then we could can make a copy of all this, and we can make our slider negative to -3 or something. and then we can make this go out. So I have two extrusions. I have one that's kind of extruding this way and one that's extruding that way. There are other ways to do this, but this is just the easiest way with the fewest new things we have to introduce. And you could go ahead and you could apply that same logic to your Soffit surface. Let's go ahead and copy all that. And then connect our Soffit to this as well. Whoa, broken. Oh, I connected the window to it. There we go. Okay, Soffit. Okay, and you know the Soffit might really want to come out like a lot further, right, to start to block some sunlight. It might create kind of a shelf. So let's experiment with these parameters a bit more. We might make this bigger. And this is just a study. We don't have to actually build this yet, but so then the Soffit might really start to come out. This might get a little bit deeper as well, some kind of a shelf. Now, if you wanted to divide this further, you know, you could put a division in here and create kind of a clear story. So then we have our section of this. Now this is all just kind of surfaces. If we wanted to make this in Rhino, remember we're going to have to bait this, and then you could change the material of this to transparent to work on your facade. So there's a really simple kind of study. And again, you know, we can look at the proportions of this, like maybe it's all glass. Go ahead and hide this line actually. Okay. You could make this Soffit more of a wedge, so you can get it very modern there, or increase the depth of it. So lots of different permutations just in that. Okay, let's go back to our lines that we used that were our window lines here, right? So we might use this to start to do some divisions in this window. Remember we made this rectangle pattern? I'm going to make these rectangular, so let's take a rectangle. Remember rectangles want a domain. I'm going to make it square, so I'm going to have the same domain, and then let's put a slider in. Remember this pattern for making a square, so take B, make this a negative B. So if we look at what this is, I'm just gonna, so that I can see this. Okay. So that rectangle that I made, you can see that it's basically a square. So if I increase this, it's 0.42, and then it's negative 0.42, and that range is from 0.42 to negative 0.42, and the same here. And so that gives me basically a square. Okay, and rectangles on a plane. What I did was I just kind of set a plane like an arbitrary plane. What I'm going to do though is I'm going to take these rectangles and I'm going to distribute them over my divide. So divide is going to give me points, and I'm going to use that for my rectangles. And so now I've got rectangles at all these points. I can go ahead and extrude these into Z. So it's starting to do that. Kind of big though, but we'll play with that later. And if we wanted to get the height of these, right? So we would take the height of this line minus the height of this line. Okay, so how do we do that? Remember we have that subtract component. So the height, so which line's which? So the height of the soffit, which is, let's see, I have to subtract there. Yeah, which is this actual subtraction, so we're actually plugging that in. And the height of the window, which is this one right here. I should probably label these better. And that's going to give me negative 12. Oh, we might need to reverse these. Yeah. Okay, so let's let's plug in the window height for B and the soffit height A. That gives me 12. Okay, and that's the height of these. Okay, so again, instead to keep track of these, soffit height comes from this component here. That's the subtraction. It's the subtraction of the maximum height from whatever I set the soffit to be, and the window height is actually the one that's here. So that's a way to get that mathematically. It's really good to label these components. I'm not doing a very good job of it. Okay, so I've got these windows here, and I can change the whether these are very large. Actually, that's not going to work in this case. Make these smaller. Make these very large pieces. I can make them very thin until they're almost not there anymore. So there's that. I could go into the divide component, change the number of these for that facade. Okay, let's take a look at those columns now. Like maybe we've got a row of columns that kind of penetrate through. Turn these division points back on. And these I might want to be, cylinders. So maybe I can go through and create a cylinder there. So these are cylindrical columns. So put a cylinder in there. Now we got a problem though. These are on the same line and they're going to kind of spring up. So we could make them engaged columns if we increase the radius to be very large. Let's just make a big column. So we could do something like that. Oh, and then the height needs to be what? The height needs to be the height of the facade. So take this 18 and plug it in. So that's one way to do it, to kind of keep those things in there. You can make them very large. Maybe they become somewhat engaged. You could also do rectangles and actually break this up a little bit differently. Another thing you could do though is to take the ground line and actually offset it. And offset creates an offset curve, just like it would seem to. Let me just go ahead and hide all this. Turn on preview. We've got our lines here. Gonna hide my cylinders for now. So if we took the ground line and we offset it, you can see that we get this line, this green line. Okay, and offset takes some kind of a distance. So I'm going to go ahead and give this larger number. So D is distance, P is a plane, plane's fine. So let's plug this in and plugged it into P. Needs to go into D. You can see you can move this line. So if we take that offset and plug that in instead of this, we can actually move our columns away from our facade. Let's go ahead and turn this back on. And so now we've got a different kind of relationship with this here. Make these a little smaller. Again, you could put like a shelf up here. You could do all kinds of different sections with this, different from what I've been showing. This is really, a lot of variation in this that you could do. You begin to explore this. Don't worry about stuff that's kind of overlapping here. You could always take care of that in Rhino and when we get more sophisticated. Now it's time to look at this in elevation. So if we look at this in a front view, we can see that there's definitely something, these are kind of off from each other. So what we probably want to do is go through and adjust the number of points we have. So we have 27 and 5, so that's not right. Let's make this 30. And that actually, so since they're multiples, that seems to make more sense. But we might actually want to go through and divide this up even further to get a more interesting facade design. So let's take our window divisions and let's do a cull pattern. So you can see that. So we have the rhythm of that. We can divide those into bays of 3 if we wanted to. Let's go ahead and put a slider in and just experiment with this a bit. Oops. There you go. Whole numbers. Let's give it to 10. So maybe, that's interesting, having 2 and then 3, 2 and then 3. So kind of experimenting with that. Again, 3s, that makes a lot of sense. Yeah, maybe not as much variation as we wanted. We could always go in and, increase the number of points. What if I did, 60? And then I could go through and experiment a bit. So this is a lot of what parametric design is really about, is just kind of experimenting with different variations. And if we know that there are so many per bay, then we could actually do some like a true false mask. So if we know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we know there's 11 things. We could do a pattern that repeats every 11 using like a cull pattern. Okay, so there's different ways of experimenting with this. So there's that. There's one design there. Could also go through and we could make a copy of this line. We could move it, and then we could extend a cross section, and we could further subdivide this. We could divide this into 2 windows and have one window, that has this pattern, and then another where this is culled even further. Okay, to create kind of a clear story window. So lots of things. So it's kind of a basic demo of how to do this facade assignment. Hopefully that kind of explains things if things went a little fast during lab. But again, I want to encourage you guys to really try something different than what I'm showing here. Again, looking at different datum lines, concentrating more maybe on horizontals, maybe experimenting with randomness and patterns as they work together. Like that might be something. Engaged columns versus columns that are disengaged. Using the dispatch component to create different types of patterns. And one last thing I want to kind of point out that you could do would be to do the kind of study that we showed with the railings, where I moved a line. So let's see here. If I go into my window line, I'm going to move a copy of the window line into Z. You can see that line showing up there. And then remember, I used a series component to create multiple copies of that line. Oh, that's actually interesting. And then you could apply a pipe to that geometry, or you could do a sweep of that geometry. So lots of different things that you could experiment with. These could become a series of louvers, kind of a series of blinds. So really a lot of variation that's possible. Let's just take a look at what I can do with this here. So I can move these up and down then. Yeah. And then I could change the spacing. The spacing is going to be a lot less. So I can make these really fine like kind of a mesh or something, or I can increase them. Maybe they're a band in the center. And then lastly, you know, I can control the number. This could be a big number or a small number. Kind of modern. Now remember, these are just lines, they're not geometry yet, so we would actually need to do something to make that geometry. But you could go through, and then if you made a lot of them, and then you could call these as well. Turn the preview off for that. Pretty interesting. And again, I could go back, and I could change my base. Got to go back and change my series now. But change the number of columns again. It's a 60, 15. It's a lot of columns. Maybe 10. They change the whole height of the thing. Change the thickness of it. And maybe it becomes engaged again. So this kind of play is really important in parametric design, just to explore the kind of variation that you might get. Okay, we could increase the size of these again, set up a different rhythm. I could go back and look at my column. Again, this is why organizing is really important. Okay, so maybe increase the scale of these, and you know, you could make these dependent on each other so that the width of this is equal to, you know, 4 times the width of the window element, right? Proportion. This is where the last assignment really starts to make sense to us. So there you have it. I mean, there, once I start to hide things, there is my study of a facade. I'm trying to turn off points here just so I can look at it. Now, if you actually want to get this in a model, right, you'd actually have to bake this geometry. And an easy way to do that is just you could take a group component and then just pipe in kind of like a loft. Just take all the geometry that you want and put it into the group. So you got to go back and find your extrusions, hold shift, just add it in there. Okay, until everything turns green. Take out my extrusions. Let's take my window loft. Let's see if I got that. Oh, columns. Pipe that in. And if everything is green in that group, when you bake it, too much zoom. Then you've got, oops, I moved my curve there. But yeah, if you look at it, I'm just going to show you Maxwell here. You've actually got some real geometry. Okay. So anyway, that's a really basic facade study. I would look at some buildings. You know, you look at some you know, like international style or Sorrenzo piano. You know, look at some architects that really understand proportion and facades. Even if you want to go Renaissance, that would be great. And just examine the different kinds of patterns that architects make, the different kinds of rhythms, right? And explore the distribution of geometry. So horizontal, vertical patterns. and submit that for your assignment on Tuesday. And if you have any questions, let me know. Thanks.